Welcome back, dear viewers. Today, we reunite for an intense exploration, the heart-stopping near crash of Southwest Airlines Flight 1380. With meticulous analysis and empathy, we'll uncover critical events and draw valuable lessons for aviation safety. Join us on this crucial journey. Your presence and engagement mean a lot. Let's begin. Southwest Airlines Flight 1380 was a regularly scheduled flight from New York's LaGuardia Airport to Dallas Love Field in Dallas, Texas. The Boeing 737-700 operating this flight was one of no less than 741 Boeing 737s in Southwest Airlines' fleet at the time, including more than 500 of the third-generation -700 model. This particular plane rolled off the assembly line in 2000 and had been flying for Southwest ever since. Its two CFM56-7B jet engines were even older. The left engine, for example, was built in 1997 and was installed on this 737 in 2012. No one knew that this particular engine concealed a tiny but dangerous flaw. The main fan disc of a CFM56 turbojet engine is made up of 24 fan blades attached to a central hub, which rotates at high speed to draw air into the engine. Centrifugal forces acting on the fan blades subject them to high loads in a radial direction, that is, outward from the axis of rotation. To keep the blades firmly in place, the root of each blade is shaped into a so-called dovetail, a wider, flanged section that slots into the rim of the fan hub, harnessing the rotational forces to hold the blade firmly in position. But CFM, the engine manufacturer, had underestimated the magnitude of the load borne by the dovetails. As the engines repeatedly started and stopped over thousands of flights, fatigue cracks began to form in the dovetails of some CFM56 fan blades at an earlier point in their life cycle than had been predicted. On the 27th of August, 2016, one of these low-cycle fatigue cracks caused the failure of a fan blade on a Southwest Airlines Boeing 737 as it approached its cruising altitude over Mississippi. The blade separated from its dovetail, struck the inside of the fan case, and dislodged the engine inlet, sending pieces of the inlet through the fuselage and into the leading edges of the wings. Thankfully, no one was killed or injured, and the plane soon made a successful emergency landing in Pensacola, Florida. As a result of the incident, the engine manufacturer issued a service bulletin calling for ultrasound inspections to detect cracks in fan blades that had accumulated more than 15,000 flight cycles since their last overhaul. Several more cracks were found, including some on the same engine, although none were as deep as the crack that caused the failure. In addition, CFM created guidelines for a more rigorous eddy current inspection technique, which uses an electrical current to detect cracks, for use during engine overhauls. But these older fan blades were not the only ones developing cracks. Another blade in Southwest's fleet, which at the time had less than 15,000 cycles, contained a crack at the top of the dovetail that had been growing since before the engine's last overhaul in 2012. During the overhaul, inspections using a fluorescent penetrant technique (FPI) failed to detect it, possibly because the crack was not yet deep enough to be seen using this method. Routine visual inspections of the blade over the next several years didn't detect the crack because it was hidden beneath the blade's copper-nickel-indium coating. The eddy current inspection at the blade's next overhaul would likely have found the crack, but that was a long way off. At the gate at LaGuardia on the 17th of April, 2018, 144 passengers and 5 crew boarded Southwest Flight 1380, bound for Dallas. Unknown to any of them, the crack had grown to a depth of 1.23 centimeters, and the fan blade was near its breaking point. In command of the flight was veteran Captain Tammy Jo Schultz, a 56-year-old former U.S. Navy fighter pilot with over 10,000 hours on the Boeing 737. She was an exceptional pilot in every regard. As a young woman, she was told that she could not be a professional pilot because of her sex, and the Air Force turned her away for the same reason, so she joined the Navy instead. After 16 years as a U.S. Navy pilot, during which she was deployed to Iraq in Operation Desert Storm, she retired and began flying passengers for Southwest Airlines in 2001, the very job she was once told she could never have. In the 17 years since, she had maintained a spotless record. Joining her in the cockpit that day was First Officer Darren Ellisor, who was also no rookie. He had previously flown in the Air Force, and had almost 7,000 hours on the 737. The passengers under their care could not have asked for a better pair of pilots. At 10:43 a.m., Southwest Flight 1380 took off normally from LaGuardia and began climbing toward its assigned cruising altitude of 38,000 feet. For 20 minutes, there were no signs that this would be anything other than an ordinary flight. But then, at 11:03, as the 737 climbed through 32,000 feet, the cracked fan blade in the left engine failed catastrophically. The crack broke clean through the blade, splitting it off from its dovetail and ejecting it from the fan hub. The fan disc is surrounded by a protective fan case, designed to absorb the high-energy impact of an ejected fan blade. Attached to the fan case is the fan cowl, the panel visible on the outside of the engine. The fan cowl consists of two semicircular sections, hinged at the top of the engine and secured by a latch on the outboard side of the bottom of the engine. Because the inboard half of the fan cowl is larger than the outboard half, a radial restraint fitting in the bottom center attaches the inboard cowl to the underside of the fan case, enhancing the cowl's structural integrity. Attached to the forward edge of the fan case is the inlet, which extends out past the front of the engine and helps funnel air into the fan disc. When the blade broke away from the rapidly spinning fan disc, it exited at approximately the 6 o'clock position, landing a nearly direct hit on the spot where the fan case attaches to the radial restraint fitting. The massive impact force was transmitted through the radial restraint fitting and into the fan cowl, which had not been designed to withstand such a collision. The impact load rippled through the fan cowl and into the latch, which sheared off the underside of the engine. The latch opened and the two halves of the fan cowl separated from each other, causing large pieces of the cowl to rip off the plane under the resulting aerodynamic loads. Simultaneously, the fan blade impact sent a wave of deformation traveling through the protective fan case. The displacement wave sheared the fasteners attaching the inlet's aft bulkhead to the fan case, while pieces of the fan blade slid forwards and damaged the structure of the inlet itself. This combination of damage sources caused the inlet to depart the airplane within a fraction of a second. As pieces of the disintegrating fan cowl and latch blew backward over the wing, a chunk the size of a cookie tray flew up and ricocheted off the left side of the passenger cabin at row 14. The impact penetrated both outer load-bearing panes of the window, causing an explosive decompression that blasted the remains of the window right off the plane. The pressurized air inside the cabin rushed out through the hole, taking with it anything that wasn't nailed down. The blast of air pushed the passenger in seat 14A head first out the window, where she became stuck half inside and half outside the plane, restrained only by her seatbelt. In the cockpit, the pilots heard a loud bang, followed by the sudden rush of air associated with an explosive decompression. A cabin altitude warning started blaring, informing them that cabin pressure had been lost. Rocked by heavy vibrations, the plane banked hard to the left, dragged down by the badly damaged engine. Inside the plane, a tornado of flying debris filled the cabin as loose objects were sucked toward the open window. Oxygen masks dropped from the ceiling and passengers scrambled to put them on. After 11 seconds, the plane's left bank reached 41.3 degrees, much steeper than at any point during normal flight. At this point, First Officer Ellisor, who was the pilot flying at the time, came to his senses and rolled the plane level. Both pilots rushed to put on their oxygen masks so they could breathe in the rarefied air at 32,000 feet, but in the confusion and chaos they struggled to activate the mask's built-in microphones that would allow them to communicate. Unable to speak to his captain and with the cockpit filled with the roar of wind noise, First Officer Ellisor did what he had to. He reduced power to both engines and began an emergency descent. Seconds later, the pilots cut off fuel flow to the left engine, completing its shutdown sequence. During this time, an air traffic controller tried twice to contact the flight but received no response. 80 seconds into the emergency, with the plane descending rapidly, the controller said, "Southwest 1380, if you're trying to get me, all I hear is static. This time, Captain Schultz replied, her voice calm and steady. Southwest 1380 has an engine fire, descending, she said. She then requested a heading to Philadelphia, which they had already determined to be the nearest major airport. Meanwhile in the passenger cabin, chaos reigned. The 3 flight attendants, armed with portable oxygen bottles, made their way down the aisle to row 14 and discovered passenger Jennifer Riordan stuck halfway out the window. They cleared out the passengers in seats 14B and 14C and tried to pull her back inside, but the extreme winds racing past the window had pinned her hard to the side of the plane. 2 passengers from a nearby row rushed to help, and through a heroic feat of strength, they managed to overcome the force of the wind and dragged Ms. Riordan back inside the plane. The flight attendants laid her out across the row of seats and began administering first aid. She was in bad shape, having suffered serious blunt trauma injuries to her face, neck, and torso. One of the flight attendants went on the public address system and asked if there was a doctor on board, prompting a paramedic and a registered nurse to take over efforts to resuscitate Ms. Riordan. Up front, the pilots had brought the plane under control, but not without difficulty. Maintaining controlled flight required continuous inputs on the yoke to counter the drag from the destroyed engine, which had lost nearly all of its aerodynamic nacelle. The controller cleared them to descend to 11,000 feet, where they would be able to breathe the air, and they certainly did not take their time getting there. Flight 1380 descended at a peak rate of over 5,000 feet per minute, fast enough to convince passengers unfamiliar with emergency procedures that the plane was out of control. Some people prayed, others purchased in-flight Wi-Fi to send messages to their loved ones. One man started streaming video of the cabin live on Facebook. But in fact the pilots were fully in command of the situation, pushing the plane down as fast as they could while running through multiple emergency checklists. During the descent, Captain Schultz repeatedly spoke with air traffic control. She declared an emergency, received clearance down to 8,000 feet, informed the controller that there were 149 souls on board, and requested that fire trucks meet the plane after landing. Descending through 13,600 feet some 6 minutes after the engine failure, Captain Schultz took over control from First Officer Elisor and they began the engine severe damage checklist. 2 minutes later, the pilots faced a decision: should they try to get the airplane on the ground as quickly as possible, or should they leave time to finish the checklists? Schultz made up her mind quickly. "Nope, just keep going," she said, before returning to her conversation with air traffic control. As they passed through 10,000 feet, both pilots removed their oxygen masks to make communication easier, and tried to debrief what had happened. As the plane neared 6,000 feet, the approach controller asked, "Southwest 1380, you going to go right in or do you need extended final?" Schultz wanted plenty of time to line up with the runway and control the descent rate before touchdown. "Extended final," she replied. First Officer Elisor attempted to contact the flight attendants but received no response. "I've got no reply from the back," he said. But less than 30 seconds later, a flight attendant managed to pick up the cockpit interphone and said, "Hey, we got a window open and somebody is out the window." "Okay, we're coming down," said Elisor. "Is everyone else in their seats strapped in?" "Yeah, everyone is still in their seats," the flight attendant said. "We have people been helping her get in. I don't know what her condition is, but the window is completely out." "Okay, we're gonna slow down," Elisor replied. Learning that there was structural damage to the airplane prompted the crew to reduce their speed. As the flight attendants informed the passengers that they would soon be landing, Elisor said to Schultz, "Okay, we have somebody that's flown outside the..." In light of this new information, Captain Schultz decided to cut short the extended final, turning straight in to begin the approach as quickly as possible. She also decided on a lower flap setting because she wasn't sure whether damage to the left wing might prevent the flaps on that side from extending, creating a serious lift imbalance. Picking up the radio to call the approach controller, she said, "Okay, could you have the medical meet us there on the runway as well? We've got Injured passengers. Injured passengers, okay, said the controller. And is your plane physically on fire? No, it's not on fire, but part of it's missing, said Schultz. In a calm and collected voice, she added, they said there's a hole, and, someone went out, a legendary transmission that perhaps rivaled Captain Sully's infamous, "We're gonna be in the Hudson." The controller was unsure what to make of this information. Bewilderment evident in his voice, he said, I'm sorry, you said there was a hole and someone went out? Yes. Southwest 1380, it doesn't matter, we'll work it out there. So the airport's just off to your right, report it in sight please. Schultz reported the airport in sight and received clearance to land. Flight 1380 was now on the home stretch to safety. In the cabin, the flight attendants faced a problem. They needed to reseat the passengers who had been in seats 14B and 14C, but this was a full flight and there were no empty seats. A flight attendant allowed one of the passengers to sit in her jump seat in the aft galley while she sat on the floor, held down by nearby passengers. The other displaced passenger and a second flight attendant also sat on the floor, the latter because she was still assisting with attempts to revive Ms. Riordan using an AED. As the plane lined up to land, Captain Schultz could be heard whispering a quick prayer before returning to her flying duties. As the passengers held their breath, unsure if they would make it, the pilots guided the plane expertly down into Philadelphia, touching down without a hitch at 11:20 a.m. As the plane rolled safely to a stop, passengers burst into applause, and Captain Schultz could be heard repeating, "Thank you Lord," over and over again. After 17 harrowing minutes, Southwest Flight 1380 at last sat firmly on the ground at Philadelphia International Airport. Since there was no immediate danger, the crew elected not to evacuate the passengers, instead requesting air stairs so that paramedics could enter the plane and remove the injured passengers first. As emergency crews hurried to the aid of Jennifer Riordan, the pilots quietly acknowledged their suspicion that she was already dead, but when speaking out loud, for fear of others hearing, they still referred to her as the injured passenger. Only a short time later, as shell-shocked but grateful passengers filed off the plane, Ms. Riordan was pronounced dead in a Philadelphia hospital. She was the first passenger to die in an accident involving a U.S. airliner in more than 9 years, and the only passenger fatality due to an accident in the history of Southwest Airlines. While the people of Albuquerque, New Mexico mourned the loss of a prominent member of their community, investigators from the National Transportation Safety Board set about finding the cause of the accident. It was immediately clear that an engine fan blade had detached in flight. But there was a problem. Like all jet engines, the CFM56 had been designed such that a fan blade failure would be contained inside the engine. So why had this protection failed? Upon closer inspection of the engine debris, recovered from the Pennsylvania countryside, investigators were surprised to discover that the protective shield technically hadn't failed at all. As designed, the broken fan blade never breached the aluminum alloy walls of the fan case. Instead, the engine had failed to hold up to a different requirement, that the nacelle structure remain intact in a so-called fan blade out event, or FBO. When the CFM56 engine was certified in 1996, CFM conducted a test demonstrating that an ejected fan blade would be contained within the fan case, proving that it met regulatory requirements. The data from the test was sent on to Boeing, which designed the fan cowl and inlet, the two pieces that together comprised the nacelle. In 1997, Boeing used state-of-the-art computer simulations to show that an FBO event occurring at various points on the fan disc would not compromise the structural integrity of the nacelle. But none of those scenarios involved a fan blade striking the fan case in the vicinity of the radial restraint fitting that held the fan cowl in place. This allowed the impact load to be transferred to the fan cowl, the exact scenario that the fan case was meant to prevent. It was a piece of the disintegrating fan cowl that caused the explosive decompression, turning what might otherwise have been a relatively normal engine failure into a fatal accident. A similar oversight also caused the separation of the engine inlet. The inlet is connected to the fan case by an attach ring that connects both to the inlet's aft bulkhead and to the inlet's inner barrel, which is made of an acoustic honeycomb material. While tests by CFM had predicted that a displacement wave in the fan case could shear the connections between the attach ring and the bulkhead, the connection to the inner barrel should have remained intact, keeping the inlet attached to the engine. However, the ejected fan blade traveled farther forward in the inlet than expected, causing greater damage to the inner barrel and compromising its structural integrity. As a result, it too failed, allowing the inlet to depart the airplane even though parts of the inner barrel remained attached to the fan case. The release of the inlet also occurred in the previous Southwest Airlines engine failure in 2016, but the mechanism behind it had not been identified. The failure mode in both cases was essentially identical, and demonstrated beyond doubt that an FBO event in the right location could circumvent all the careful design work that had been done to ensure the engine remained intact. The NTSB doubted that Boeing could have predicted this behavior with the technology and regulations in place at the time the nacelle was certified. The Southwest 1380 accident therefore represented a rare example of a mechanical failure not caused by any form of negligence, but by an unforeseen edge case that had never previously been considered. The NTSB did find one other area where safety improvements would be needed. According to the Southwest Cabin Crew Manual, all the flight attendants should have been seated in their jump seats during the landing in case an emergency evacuation was needed, but 2 of them were instead seated on the floor. Had the landing somehow gone wrong, they could have been seriously injured, preventing them from coordinating the passenger evacuation. But at the same time, flight attendants were supposed to reseat displaced passengers, who also should not have been seated on the floor. These 2 rules created a paradox because they did not account for a situation in which there was an in-flight loss of seating capacity. Because 3 seats in row 14 were unusable, there were more people on the plane than there were seats for them to sit in, creating an unsafe condition on landing. This had never been an issue in the past, only recently have optimization tools allowed airlines to routinely dispatch aircraft with every seat filled, a situation which used to be rare. As a result of its findings, the NTSB issued 7 recommendations, including that Boeing redesign the CFM56 engine fan cowl to ensure that it stays intact during an FBO event, even if the fan blade strikes in a critical location, that manufacturers in the US and Europe assess other engines to find out if they have similar weak points. That Southwest Airlines emphasized to its cabin crew the importance of being seated in the appropriate jump seat during an emergency landing, and that the FAA develop guidance on what to do in the event of an in-flight loss of seating capacity. While efforts also exist to prevent fan blade failures, inspectors cannot be counted on to discover 100% of cracks 100% of the time. Once in a while, a cracked blade will slip through under the radar. This is why it is so important that engines be able to contain the damage from an ejected fan blade, so that a failure that is hard to prevent never endangers the safety of an aircraft. Flight 1380 served as a reminder of the importance of thorough testing to find design weaknesses that might allow such an event to spiral out of control. After the accident, the FAA ordered ultrasonic inspections of all high-cycle CFM56 fan blades. Southwest went even further, announcing extra inspections of fan blades on all of its CFM56 engines. Since Flight 1380, there hasn't been another similar engine failure. As for the plane itself, it has not flown passengers since the accident, and sits in storage in Victorville, California to this day. The pilots had a somewhat happier outcome. Captain Schultz received an official commendation from Congress, and all the crew members were praised for their heroism in a reception at the White House. For a moment, they were celebrities, and 2 years later, many still fondly remember Captain Tammy Jo Schultz and her nerves of steel that helped bring Southwest Flight 1380 back from the brink of disaster. As we conclude this video, we want to express our heartfelt gratitude to all of you, our dedicated viewers, for joining us on this intense and compelling exploration of the near crash of Southwest Airlines Flight 1380. Your unwavering support and engagement have been invaluable throughout this journey. We are deeply appreciative of your feedback and contributions, which have helped us grow and improve as a channel. Your insightful comments and suggestions inspire us to continue delivering meaningful content that fosters understanding and empathy within our community. Our commitment to aviation safety and the pursuit of knowledge remains steadfast, and it is through your support that we can continue to shed light on crucial events in aviation history. Once again, thank you for being a part of this crucial expedition. Let's continue our pursuit of understanding and learning together. Until next time, take care and safe travels.